The 1970s were supposed to be the decade when farming got safer. Regulations were tightening, manufacturers were responding to safety concerns, and the agricultural industry was finally acknowledging that too many farmers were dying in tractor accidents that could have been prevented. But before those changes took hold, before rollover protective structures became mandatory, and before PTO guards were standard equipment, some genuinely dangerous tractors rolled off assembly lines and onto farms where they killed and maimed operators who trusted that manufacturers had built machines that were safe to operate. Today, we're counting down 12 of the most dangerous 1970s tractors, from machines with exposed power shafts that grabbed clothing in milliseconds to tractors so unstable they rolled at the slightest provocation, from brake systems that failed on hills to articulated frames that jackknifed without warning. These weren't just poorly designed tractors. These were machines that accumulated such horrific safety records that some faced temporary restrictions, recalls, and retrofits that manufacturers were forced to implement before the body count became unbearable. This is the story of agricultural equipment that proved too dangerous to continue unchanged. Number 12. Steiger Wildcat. The early 1970s. Steiger Wildcat takes the 12th position as an articulated frame tractor, producing over 200 horsepower that created jackknife accidents and poor visibility issues, leading to safety concerns that required redesigns before later models could achieve acceptable safety standards. The articulated design featured two separate frame sections, joined by a hydraulic pivot, creating steering through bending the tractor rather than through turning the front wheels, a configuration that was efficient for distributing power across all four drive wheels, but that created unique hazards when the articulation wasn't properly controlled or when operators didn't understand the dynamics that articulated steering created. The jackknife accidents occurred when the articulation angle became too extreme during tight turns, or when operating on slopes where gravity and momentum could force the two frame sections into angles that created instability and that sometimes resulted in the tractor folding completely, with the rear section striking the cab, or with the frame jackknifing so severely that recovery was impossible and rollover became inevitable. The visibility was compromised by the articulated design, with the long hood and the frame joint, creating blind spots that prevented operators from seeing implements or obstacles that conventional tractors with fixed frames would allow monitoring, creating situations where operators working near buildings or other equipment couldn't see hazards until collision was unavoidable. The power was substantial, with engines producing over 200 horsepower through configurations that varied depending on the specific model and year, creating pulling capacity that was genuinely impressive, but that required sophisticated control systems, ensuring that the power could be managed safely during the articulation that steering required. The early models lacked some of the safety features that later Steigers would incorporate, including better visibility through improved cab placement, more sophisticated hydraulic controls, managing articulation angles, and operator training emphasizing the unique characteristics that articulated tractors created and that required different techniques than conventional tractors demanded. The hydraulic system controlling the articulation could develop leaks or pressure losses that would reduce the operator's ability to control the steering angle, creating situations where the tractor wouldn't respond properly to steering inputs, and where the articulation could occur too slowly, preventing evasive maneuvers, or too quickly causing abrupt direction changes that could initiate rollovers. The maintenance requirements were more complex than conventional tractors, with the articulation joint requiring regular inspection and servicing that many farmers weren't accustomed to performing, leading to situations where worn components or inadequate lubrication would cause the articulation to become stiff or unpredictable, affecting the steering response in ways that could catch operators unprepared. The weight distribution changed dramatically during articulation, with the act of steering shifting loads between the front and rear frame sections in ways that affected traction and stability, creating dynamics that operators needed to understand and anticipate, rather than assuming that the Steiger would behave like conventional tractors they had operated for years. The learning curve was steep, with operators transitioning from conventional tractors to articulated Steigers, needing substantial time and experience, developing the instincts and techniques that would allow them to operate the machines safely. But many farmers were thrust into operating Steigers without adequate training, because the dealers and manufacturers hadn't yet developed comprehensive programs teaching the skills that articulated tractors demanded. The size and power made mistakes more consequential. With the Steiger's mass and the forces it could generate, meaning that errors in judgment or technique that might be merely embarrassing on smaller conventional tractors could result in serious accidents when operating a machine that weighed several tons and that possessed the power to pull implements that themselves weighed thousands of pounds through soil that resisted with tremendous force. The safety redesigns in the late 70s addressed the most critical issues, with Steiger implementing improvements that made articulated tractors safer and that allowed the company to continue building the high-horsepower machines that large-scale farming operations demanded for working the vast acreage that characterized Great Plains agriculture. The legacy is mixed, with Steiger's articulated tractors being recognized as innovative and powerful, but with the early safety issues serving as reminders that new technology required careful development and that rushing products to market without adequately addressing safety could create problems that damaged reputations and that harmed the operators who trusted that manufacturers had built equipment that was safe to use. Number 11. Leyland 270. The Leyland 270, from 1972 through 75, featured a 70-horsepower diesel that suffered from brake failures and weak clutch systems, creating dangerous situations where operators couldn't stop tractors safely or couldn't disengage implements when necessary for preventing accidents. The brake system used components that proved inadequate for the tractor's weight and for the loads that agricultural work imposed, creating situations where brakes would fade during sustained use or where they would fail completely, leaving operators unable to stop on hills or when approaching obstacles that required emergency stopping. The clutch weakness manifested as slipping during heavy pulling or as difficulty disengaging when operators needed to separate the engine from the transmission and implements, creating scenarios where implements continued operating when they should have stopped or where the tractor couldn't effectively transfer power to the ground because the clutch was slipping under load. The combination of brake and clutch problems created particularly dangerous situations on slopes where operators needed reliable brakes for controlling descent and where clutch failure could mean losing the engine braking that was essential for maintaining safe speeds on downhill grades. The market response was swift, with reports of accidents and near misses leading to investigations revealing that the Leyland 270's brake and clutch systems were inadequate, resulting in the tractor facing restrictions in the UK market, where safety authorities and farming organizations raised concerns about the number of incidents involving Leyland 270s compared to comparable tractors from other manufacturers. The temporary market restrictions damaged Leyland's reputation in agricultural equipment at a time when the company was already struggling financially and when competition from Japanese and other European manufacturers was intensifying in markets where Leyland had traditionally been strong. The legacy serves as a reminder that even established manufacturers with long histories could produce equipment with serious safety deficiencies when cost-cutting or inadequate testing allowed systems that were marginal in design to reach production and to be sold to farmers who trusted that the equipment they purchased would perform safely under the demanding conditions that agricultural work created. Number 10. Zetor 5511. The 1970s. Zetor 5511 featured a 55-horsepower diesel with poor stability on slopes, causing frequent rollovers that led to safety complaints, resulting in the model's discontinuation. The stability issues stemmed from a combination of factors, including a relatively high center of gravity, narrow track width that didn't provide adequate base for resisting side slopes, and weight distribution that concentrated mass toward the rear, creating situations where the front end would lift during pulling and where the tractor would tip rearward during steep climbs. The rollover accidents were particularly common on side slopes, where the narrow track width and high center of gravity combined to create tipping that occurred suddenly, and that gave operators minimal warning before the tractor began to roll, creating scenarios where experienced farmers who understood the dangers of slopes found themselves in rollovers because the Zetor's stability limits were lower than what other tractors could handle safely. The lack of rollover protective structures on many Zetor 5511s meant that rollovers were often fatal, with operators being crushed under tractors weighing several thousand pounds and offering no protection when they landed on their sides or completely inverted. The complaints accumulated from operators and from safety organizations, recognizing that the Zetor 5511's rollover rate was substantially higher than comparable tractors, creating pressure on the manufacturer and on importers who were responsible for bringing Zetors into markets where they were sold. The discontinuation came as Zetor recognized that the 5511 safety record was damaging the brand's reputation and that continuing production would create ongoing liability and would prevent the company from moving forward with improved designs that addressed the stability issues that had made the 5511 problematic. The Czech manufacturer eventually introduced improved models with better stability through wider track widths, lower centers of gravity, and standard rollover protective structures that provided protection when rollovers occurred despite improved stability, making them less likely. The Zetor 5511 serves as an example of how tractors that were adequate in flat conditions could become genuinely dangerous on slopes, and how stability needed to be a primary design consideration rather than an afterthought that was addressed only after accidents revealed deficiencies. Number 9. David Brown, 995. The David Brown 995 from 1971 through 76 featured a 72-horsepower diesel with steering linkage failures that caused loss of control, leading to the tractor being withdrawn from several European markets temporarily until modifications could be implemented. The steering system used linkages and components that proved inadequate for the stresses that agricultural use imposed, creating situations where connections would loosen, pins would wear, or components would fail completely, leaving operators without steering control at moments when they needed to avoid obstacles or to maintain course on slopes where loss of steering could result in the tractor traveling in unintended directions. The loss of control accidents were terrifying, with operators discovering that steering inputs weren't being transmitted to the wheels, creating scenarios where the tractor continued in whatever direction momentum was carrying it, regardless of how frantically the operator worked the steering wheel, attempting to regain control. The failures typically occurred gradually, with increasing play and looseness in the steering providing warnings that something was wrong, but farmers operating under time pressure or who lacked mechanical understanding sometimes continued using tractors with deteriorating steering systems until complete failure occurred at moments when the tractors were moving and when loss of control created immediate danger. The European market withdrawals were temporary, with David Brown and importers recognizing that the steering problems needed to be addressed before additional 995s could be sold in regions where authorities had documented the steering failures and where safety concerns had reached levels requiring action. The modifications included stronger components, better quality control during manufacturing, and revised maintenance schedules, emphasizing steering system inspection at intervals that would identify developing problems before they progressed to complete failure. The David Brown 995's steering problems serve as reminders that even seemingly simple systems like steering required adequate engineering and quality manufacturing, because failures in systems that operators depended on for basic control could transform tractors into unguided projectiles that would travel until they struck something, or until they rolled on terrain that couldn't be safely traversed without steering inputs maintaining proper course. Number 8. Fiat 640. The 1970s export model Fiat 640 featured a 60-horsepower diesel with an exposed PTO shaft that caused limb injuries, leading to the tractor facing temporary restrictions in the UK until proper guards could be retrofitted. The PTO exposure was the result of inadequate shielding, leaving the rotating shaft accessible during normal operation, creating entanglement hazards where loose clothing, gloves, or even hands could contact the spinning shaft and be grabbed instantly with the rotation wrapping material around the shaft faster than human reflexes could respond. The limb injuries were severe, with the rotating PTO shaft acting as a drum, winding up anything that contacted it, pulling victims toward the shaft with forces that increased as more material wrapped, and that created leverage, pulling bodies into machinery that continued rotating until clothing tore, limbs separated, or the engine was shut down by someone other than the victim who was trapped in the machinery. The injuries often resulted in traumatic amputations, with fingers, hands, or entire arms being pulled into the PTO shaft and being twisted or torn off by the rotational forces and by the victim's body weight being pulled against the wrapping that the shaft created. The UK restrictions were implemented after documentation showed that the Fiat 640 was involved in a disproportionate number of PTO entanglement accidents compared to other tractors, creating recognition that the inadequate guarding was directly causing injuries that proper shielding would prevent. the requirement for retrofitting guards before additional Fiat 640s could be sold, or before existing examples could continue operating legally forced Fiat and importers to supply and install shielding that covered the PTO shaft adequately and that prevented access during normal operation. The Fiat 640's PTO problems highlight how the seemingly obvious requirement for guarding rotating shafts wasn't universally implemented during the 1970s, and how tractors could be exported from one market where regulations were lax to other markets where safety standards were higher, creating situations where equipment that was legal in its country of origin became illegal or restricted in export markets that had implemented better safety regulations protecting agricultural workers. Number 7. Case 1. 070 Agri King. The Case 1 070 Agri King from 1970 through 74 featured a 108 horsepower diesel with a cab that lacked rollover protection, contributing to frequent overturn fatalities that led to the model being replaced by the 90 series equipped with rollover protective structures. The rollover accidents were the leading cause of tractor-related deaths during the 70s, with statistics showing that approximately half of all fatal tractor accidents involved rollovers, where operators were crushed when tractors landed on them after tipping sideways or backwards. The 1070's cab provided weather protection and comfort, but offered no structural strength that would protect operators during rollovers, creating false sense of security, where operators felt protected by the enclosed cab, not realizing that the structure would collapse completely when thousands of pounds of tractor rolled onto it. The frequent fatalities associated with the 1070 created pressure on Case from safety advocates, from families who had lost members in rollover accidents, and from insurance companies recognizing that the liability associated with tractors lacking rollover protective structures was becoming unsustainable. The replacement with the 90 series represented Case's response to the safety crisis, with the new models featuring ROPS as standard equipment rather than as optional accessories that many farmers declined purchasing due to cost concerns or due to belief that rollovers wouldn't happen to them. The ROPS frames were designed to withstand the forces that rollovers created, maintaining a protected zone around the operator station and preventing the crushing that occurred when cabs collapsed or when operators were ejected and then crushed by tractors rolling over them. The Case 1070 Agri King serves as an example of the transition period, when manufacturers were beginning to recognize that rollover protective structures needed to be standard equipment rather than options, and when the agricultural industry was acknowledging that the costs of installing ROPS were justified by the lives that would be saved when rollovers occurred, despite operators' best efforts to avoid the slopes, loads, and terrain features that created tipping hazards. Number 6. Oliver 1-850. The Oliver 1-850, from 1970 through 74, featured a 92 horsepower diesel with a poor braking system that caused downhill runaways, resulting in the tractor facing temporary withdrawal after multiple fatal accidents documented the brake system's inadequacy. The brake problems stemmed from undersized components that couldn't handle the tractor's weight, plus the implements and loads that agricultural work imposed, creating situations where brakes would overheat during sustained use or would simply lack adequate stopping power when operators needed to control speed on hills or to stop quickly when hazards appeared. The downhill runaways occurred when operators descended grades that exceeded what the brakes could manage, with the brakes fading as friction material overheated, and with the brake pedal eventually reaching the floor without producing meaningful deceleration, leaving operators helpless as the tractor accelerated down slopes, gathering momentum that made collision or rollover inevitable when curves or obstacles appeared in the path. The fatal accidents often occurred when runaway tractors struck buildings, vehicles, or other equipment at the bottom of hills, or when operators attempted to turn away from hazards, and the speed combined with the turning to initiate rollovers that crushed operators under tractors that had become uncontrolled projectiles. The temporary withdrawal came after investigations revealed that the Oliver 1-850's brake system was inadequate, and that the accidents weren't the result of operator error or poor maintenance, but were inherent in the design that had been approved for production, despite the inadequate braking capacity. The multiple fatalities created liability concerns that made continuing production untenable until Oliver could implement brake system improvements that would provide the stopping capacity that safe operation required. The Oliver 1-850's withdrawal serves as one of the clearest examples from the 1970s of a tractor being removed from the market due to specific safety deficiencies that had been documented through multiple fatal accidents, creating a situation where the manufacturer acknowledged that the design was inadequate and that continuing sales would be irresponsible given the known dangers that the brake system's limitations created. Number 5. Massey Ferguson 165. The 1970s. Massey Ferguson 165 featured a 58 horsepower diesel with a narrow front axle design that was prone to tip-overs, leading to temporary restrictions in some European markets until axle redesign could be implemented. The narrow front axle positioned the two front wheels close together, creating a configuration that was useful for row crop cultivation, where the narrow wheels could pass between rows without damaging plants. But that created stability problems by reducing the front track width that provided resistance to sideways tipping. The tip-over accidents occurred when the narrow front axle couldn't provide adequate stability on side slopes, or when turning on slopes where the combination of the slope angle and the centrifugal force from turning overcame the narrow front track's limited resistance to tipping. The rollovers could happen suddenly without adequate warning, with the narrow front axle allowing the tractor to tip past its stability limit and to begin rolling before operators could react, creating situations where experienced farmers found themselves in rollovers because they had misjudged the Massey Ferguson 165's stability limits, or because conditions changed more rapidly than they anticipated. The European market restrictions were implemented temporarily in regions where authorities had documented that the narrow front axle design was contributing to rollover accidents at rates that were unacceptable and that required action, preventing additional 165s with the problematic front axle design from being sold until modifications could be implemented. The axle redesign provided wider front track width that improved stability and that reduced the rollover risk to levels that were comparable to other tractors with conventional front axle configurations. The Massey Ferguson 165's front axle problems highlight how features that were useful for specific applications like row crop cultivation could create safety compromises that weren't acceptable when the broader range of conditions that tractors encountered during actual farm use were considered. The narrow front axle might have been adequate in flat fields with perfect conditions, but agricultural reality included slopes, turns, and uneven terrain where stability became critical and where the narrow track width proved inadequate. Number 4. Allis Chalmers 190XT. The Allis Chalmers 190XT from 1970 through 73 featured a 93 horsepower diesel with transmission failures that caused runaway accidents, leading to the model being temporarily pulled from some regions and being replaced by the 200 series with improved transmissions. The transmission problems manifested as inability to hold tractors stationary when parked on slopes, as unexpected motion when operators believed transmissions were in neutral, or as failures during operation where transmissions would lose their ability to transmit power or to provide braking, creating situations where tractors became uncontrolled and where operators had minimal options for stopping or controlling motion. The runaway accidents were terrifying, with operators discovering that the tractor was moving despite the transmission supposedly being in park or neutral, creating scenarios where the tractor would roll down slopes gathering speed as gravity accelerated the uncontrolled machine toward whatever obstacles or hazards existed at the bottom. The transmission failures during operation were equally dangerous, with operators losing power or losing the ability to slow down when transmissions failed internally, creating situations where tractors continued moving at whatever speed they had achieved when the failure occurred. The regional restrictions were temporary, with Allis Chalmers and dealers recognizing that the transmission problems were creating unacceptable safety risks, and that continuing to sell 190XTs in areas where the problems had been documented would create liability and would damage the company's reputation further. The replacement with the 200 series represented Allis Chalmers' acknowledgement that the 190XT's transmission wasn't adequate and that a fundamentally improved design was necessary, rather than just implementing minor modifications to the existing transmission that had proven problematic. The Allis Chalmers 190XT serves as an example of how transmission problems, while perhaps seeming less dramatic than rollover or PTO entanglement hazards, could create genuinely dangerous situations where tractors became uncontrolled and where operators had minimal ability to prevent accidents once transmissions failed to perform their fundamental function of controlling motion and providing the mechanical advantage that tractors required for safe operation. Number 3. John Deere 4230. The John Deere 4230, from 1973 through 77, featured a 100-horsepower diesel with hydraulic leaks that led to fires plus poor operator protection, resulting in early models being recalled and later examples being fitted with better cabs and fireproofing. The hydraulic leaks developed from hoses, fittings, or seals that failed, allowing pressurized hydraulic fluid to spray onto hot engine components, where the fluid would ignite, creating fires that could spread rapidly once started and that could engulf entire tractors within minutes if operators didn't react quickly with fire extinguishers or by abandoning the equipment before flames reached fuel tanks. The fires were particularly dangerous because hydraulic leaks often occurred in locations that weren't immediately visible to operators, allowing leaks to spray fluid onto hot exhaust manifolds or turbochargers where ignition was almost certain once sufficient fluid had accumulated on surfaces that were hot enough to ignite petroleum-based hydraulic oil. The poor operator protection in early models meant that cabs lacked adequate fireproofing and that escape routes could be blocked by flames that spread quickly once fires started, creating scenarios where operators were trapped in burning tractors or where they suffered severe burns during escape through flames that were blocking doors or that had already entered the cab. The recalls were implemented after John Deere acknowledged that the hydraulic system design was creating unacceptable fire risks and that the cab design wasn't providing adequate protection if fires did occur. The retrofitting of better cabs and fireproofing on later models represented John Deere's response to the safety issues, with the company implementing improvements that reduced leak probability through better components and better routing of hydraulic lines away from hot engine areas, while simultaneously improving cab construction with fire-resistant materials and with better escape routes, ensuring that operators could exit quickly if fires did occur, despite the improvements intended to prevent them. The John Deere 4230's fire problems serve as reminders that hydraulic systems, while essential for modern tractor operation, created fire hazards that required careful engineering, ensuring that leaks couldn't occur in areas where ignition sources existed, and that required cab designs providing protection and escape routes if fires occurred despite preventive measures that were implemented. Number 2. International Harvester 1066. The International Harvester 1066, from 1971 through 76, featured a 414 cubic inch diesel producing 125 horsepower with PTO shielding failures that caused severe injuries, leading to safety recalls, forcing redesign of PTO guards. The shielding failures occurred when guards designed to cover the rotating PTO shaft would break, fall off, or be removed by operators who found them inconvenient and who didn't understand that the moment of inconvenience during installation or during operation was insignificant compared to the catastrophic injuries that exposed PTO shafts could cause. The severe injuries from PTO entanglement included traumatic amputations, where limbs were torn off by the rotating shaft, severe lacerations, where clothing wrapped around the shaft dragged victims across the machinery, cutting and tearing flesh, and deaths when entanglement occurred far from help and when victims bled out before assistance could arrive, or when the wrapping around the shaft crushed or strangled victims who couldn't escape. The PTO shaft's rotation at 540 or 1,000 RPM, or revolutions per minute, meant that entanglement happened faster than human reaction time could respond, with the shaft completing multiple rotations and wrapping substantial amounts of clothing or pulling bodies entirely into machinery before victims could even register what was happening. The safety recalls were mandatory, with International Harvester being required by safety authorities to implement redesigned PTO guards that were more durable, that were more difficult to remove, and that provided better coverage of the rotating shaft, even when implements were connected or disconnected. The redesign addressed not just the physical strength of the guards, but also the mounting systems, ensuring that guards remained attached during normal operation, and that replacement guards were readily available when damage occurred, requiring replacement. The International Harvester 1066's PTO problems highlight how even well-established manufacturers building tractors that were otherwise solid and capable could have critical safety deficiencies in specific systems, and how the consequence of those deficiencies could be horrific injuries that permanently disabled victims or that killed them through entanglement in machinery that should have been adequately guarded, preventing contact with rotating components that were inherently deadly when exposed. Number 1. Ford 5000. The early 1970s, Ford 5000 takes the top position as one of the most dangerous tractors from the decade, featuring a 75 horsepower diesel with a high center of gravity, creating rollover risk without rollover protective structures. That was so severe, the tractor faced temporary withdrawal from some markets until safety retrofits could be implemented. The high center of gravity came from the engine and component placement that positioned substantial mass relatively high in the frame, creating a situation where the tractor's center of gravity was elevated compared to more stable designs, and where the rollover threshold was lower than what comparable tractors from other manufacturers could safely handle. The rollover risk was substantial, with the Ford 5000 being involved in numerous fatal accidents, where operators were crushed when tractors rolled sideways on slopes that seemed manageable, or rolled backwards when front wheels lifted during pulling, and when the tractor pivoted around the rear axle, continuing through a complete backward roll. The lack of rollover protective structures on many Ford 5000s meant that these rollovers were often fatal, with operators having no protection when several thousand pounds of tractor landed on them. The temporary withdrawal from some markets came after safety authorities and agricultural organizations documented that the Ford 5000's rollover rate was unacceptably high, and that continuing to sell tractors without adequate stability or without rollover protective structures was creating an ongoing pattern of fatal accidents that required intervention. The safety retrofits included options for installing rollover protective structures on existing Ford 5000s and modifications to improve stability through ballasting or through operational restrictions, limiting the slopes and conditions where the tractors could be safely used. The market impact was substantial, with Ford's reputation being damaged by the safety issues and by the acknowledgement that the 5000 required retrofits before it could meet acceptable safety standards. The retrofitting programs were expensive and logistically challenging, requiring dealers and service centers to install rollover protective structures on thousands of tractors that were already in service, creating costs that Ford absorbed and creating inconvenience for farmers who had to bring tractors in for modifications. The Ford 5000 serves as perhaps the clearest example from the 1970s of a popular, widely sold tractor that had fundamental safety problems, serious enough to require temporary market restrictions and extensive retrofitting programs, addressing deficiencies that shouldn't have existed when the tractors were originally designed and sold. The high center of gravity and the resulting rollover risk weren't subtle problems that only became apparent through years of use. They were inherent design characteristics that proper engineering during development should have identified and corrected before production began, and before farmers purchased tractors that would kill them through rollovers that more stable designs would have avoided. These 12 most dangerous 1970s tractors prove that agricultural equipment from that decade harbored deadly hazards that killed and maimed operators until safety regulations, manufacturer recalls, and temporary market restrictions finally forced the changes that should have been implemented from the beginning. From exposed PTO shafts to inadequate rollover protective structures, from failed brakes to steering systems that collapsed, these were the features that made farming one of the most dangerous occupations, and that created the safety crisis that eventually forced the agricultural equipment industry to prioritize operator protection over cost savings and traditional designs that were familiar but deadly. Which of these dangerous tractors do you remember? Share your experiences below. Subscribe now. More agricultural history and safety stories coming soon.